Okay, for this next several sections, let's take a look at the learning objectives. Now, first of all, before I even get into what I'm about to work with you here, this next several videos, 6 or 8, whatever it is, are going to be very, very, very quick, very brief review. This is an algebraic review, just to kind of get you thinking in terms of some of the stuff that you need to be familiar with or reminded of to be successful in the calculus class. Now, the whole point behind these next several videos is going to be a review functions and function notation, and I'm going to take a look at a quick review of trigonometric functions. Now, first of all, let's take a look at simply what a function is. A function f is a rule that assigns to each value of x, and typically when we use x like that, we're thinking of a value on the horizontal axis, in a set D, and this D is actually the domain, a unique value which is denoted by f of x. And f of x is what we really typically think of as simply being y. Now, and y is also, we think of this as being the range. Okay, so let's just draw a quick picture here and see if it'll help out a little bit. So we have the domain. And this domain is going to have a bunch of x values using this notation. So like x1, x2, yada, 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 out to xn. And over here is the range, which would be y1, y2, out to yk. I use n and k because these don't have to have the same number of values in it. So over here, I'm going to make this box, and I'm going to say this is my function f. Now, this rule, what it does is it takes a value from the domain, sends it to the function, and then the function sends it to some value in the range, and it's a unique value. A unique value simply meaning that you notice here, this x1 went to y2. It did not go to y2 and y1. If that situation happened, then it would not be unique, and that would not be a function. So all these values of x go into the function and then is mapped to some value of y someplace. That's the whole idea. Now notice I could have an x here that goes into the function, and this could share the same y. That's okay, because for this particular value of x, it only goes to one unique value of y. It's not going to two y's. Let me draw a couple pictures here in terms of graphs. Now suppose we have, let's see, xy axes, and I have something like f of x equals x squared. So it's just a quadratic. Well, if this is x1, x1 goes to this value of y. And over here, there's another x. I'm going to say x sub j. I don't know which x it is. Doesn't really matter. It's just another x. Well, guess what? That goes to the same value of y. Perhaps this is -2 and 2, and perhaps y is 4, because I said this is x squared. F of x equals x squared. Well, this is a function. There's no problem, but this is a function because this x only goes to one y. It just happens to be that we're sharing that y. Now, if I had a graph that looked perhaps something like this, this is not a function because, see, I have an x right here that goes to this y, and this y. It does not go to unique y. As a quick reminder, hopefully you recall the vertical line test. The vertical line test simply says if I draw vertical lines all the way through my graph everywhere, nowhere where I find any point where this vertical line would touch the graph more than once. Here, that's not true. A vertical line touches it 1, 2, 3 times. Or perhaps here, the vertical line would touch it 1, 2 times. So this is not a function. Whereas this is a function. A linear function, something like this, that's clearly a function. It passes the horizontal line test everywhere. A circle is clearly not a function. That fails the vertical line test miserably. So anyway, that's just a really quick review of the idea of what functions are.